Okay, good. Now we've got quite a few people on the Google Meet and some people here in class. So those of you that are on the Google Meet, we have some people that were invited back to the school, and that means I have to wear a mask. So I'm going to try to talk much louder than I normally do so that it's not muffled by the mask. We have our last test. And that's what, especially the people that are in here, we're trying to make sure you've got everything you need to be successful on that last test. But everybody out there on Google Meet as well. So, quick reminder, you need to check your emails. There were a few of you that did not submit your work for the test. And that means major deductions if you didn't show me that, because a lot of it said show the factored form. So I have to see your factoring as you do that. So like I said, make sure you check your email at some point today. If you don't have a packet, because they were online for you to print out, but if you don't, again, just grab notebook paper and make sure that you are labeling very carefully. You know, like when we go through example 1, put 5-4, example 1, you know, those types of things so you can keep track of where everything is, and then you should be fine. All right, last test of the year will be on sections 5-4, 5-5, and 5-6, just 3 sections. And they're kind of fun little sections, so hopefully as we go through them, you'll start thinking, oh yeah, I kind of remember pieces of this. I've done this stuff before. Our objectives, we're going to divide polynomials using long division. Now you haven't divided polynomials with long division before, but you've done long division, so you already have a little bit of an up on this game, because you can say, well, I know how long division works, so maybe I'll use that to try to figure out polynomial long division. And then tomorrow, we'll start hitting divide polynomials using synthetic division, which is a very cool process. You're going to love that when we get to that. Essential understanding, this is what we have to know to do well on the test. You can divide polynomials using steps similar to the long division steps that you used to divide whole numbers back when you were in elementary school. So the steps are very, very similar. When you try to factor a polynomial, you're trying to find a divisor, something that divides evenly into the polynomial. So it gives a quotient, which is the other factor, but most importantly, a remainder of 0. That's what we're looking for. This suggests that being able to divide one polynomial by another could help you factor it. So if anybody's ever had trouble with factoring, this gives another method that you can try to factor. Numerical long division and polynomial long division, they're very similar. So let's start off with, back in elementary school, when they said, here's 672 divided by 21. Now, what you didn't do was sit and write down 21 times 1, 21 times 2, 21 times 3, until you got close to 672. That's not how you were taught, because there's a method to this that says, don't look at the whole number at once. Only look at what you need. So start with the first number underneath the division symbol, a 6, and think, will 21 go into 6? No, that doesn't make any sense. So then put the first 2 numbers together. 67. Oh yeah, 21 will go in there. Well, let's see, I think 3 times. So off on the side, you do a little bit of this and get 63 and say, yep, that's going to work. So I'm going to put a 3 right here, and I write it down. And then what did you have to do? Yeah, you had to subtract. Now remember that, because that's going to be good for polynomials as well. We have to subtract it. So you did 67 minus 63, and you got a 4. But you weren't done, right? So what did you have to do? Bring down the 2, exactly. Bring down that next digit. And then you said, oh, 21, I know that will go into 42. Oh, I think twice. Oh, look at that, it goes in perfectly. And again, you did your subtraction and you wrote down that 2 worked. So thinking backwards, what you just found was 21 times 32 equals 672. You found the factors, and they went in perfectly. And we know that because our remainder was 0. Now, it doesn't always happen that we get, that perfect remainder of 0 going on there, but that sure was nice to have one that worked out beautifully and perfect. And every once in a while, that's going to happen with our polynomial long division too. But we need to learn it both ways, if it comes out nice and if it doesn't come out nice. So now we switch gears. We're going to use polynomial long division to divide. Now you use the same kind of symbols. Going to be a much longer division symbol this time because we've got a polynomial underneath there. And we're going to divide that by 2x plus 1. That's our divisor. That's the fancy name for that. And 6x squared plus 7x plus 2 would be our dividend. Now, just like we did with normal long division, we don't try and get the whole thing to match. That wouldn't make any sense. We would have been there all day. 21 times 1, 21 times 2, 21 times 3, until we got to 32, and we probably would have said, let's skip some and then try to work our way back. But it would have taken too long. Same thing here. We start with only the first term. So here's what I have. I have a 2x. If I want to get rid of this first term, which is the 6x squared, let me underline that for the people that are on the Google Meet there. I have to figure out what do you multiply 2x by to make it match 6x squared. What does it need? Needs a 3. What else? An x, exactly. So we're going to multiply the quantity 2x plus 1 times 3x. Now, if you're thinking, but I'm going to get something else in the back because there's a 1 there, you're absolutely right. But we don't have any control over that, and we don't want to worry about it. Just the first terms. So 6x squared plus 3x. Now, at this point, when we did normal long division, didn't we have to subtract? So the problem with polynomials is there's a lot to keep track of. So it would be much easier if we went ahead and changed their signs and just added instead of subtracting. So we're going to change these signs once my blue marker turns on and add them vertically. So 6x squared plus a negative 6x squared. Yes, I know it looks like subtraction anyway, and that's the good part of it. It's going to look like subtraction. That'll be 0. And this is where we give ourselves one of these. Yes! Because we did it right. I mean, the first term was all we were trying to get rid of. 7x minus 3x, yeah, we can't help it. That's going to happen. So that'll be 4x. Now, since I did get a 0 in those x squareds, I know that 3x worked. When something works, we want to line it up vertically with the other terms. This was an x, so we're going to line it up right on top of all the x's going down. Well, at this point, with normal division, we had to bring down the next term. That's what we're going to do here. Bring down that 2. And now start over. Think only of the first term. So we're going to come over here and go with that 2x plus 1 again. And we're going to figure out, how do I get 2x to be 4x? What would I need to do? Multiply by 2, exactly. We're going to multiply by 2, 4x plus 2. We're not going to forget to change the signs and add. And look at that one. It went in perfect. So I know that my little 2 worked. Boy, did it ever work. And a nice side effect is now I know how to factor 6x squared plus 7x plus 2. Because this times this has to equal that dividend. So 2x plus 1 times the quantity 3x plus 2 equals 6x squared plus 7x plus 2. Now, here's the reality of the situation. Most of you are super at factoring. You spend exponential doing practically nothing but, But if you were stuck, it'd be a good way to get yourself unstuck, thinking about how to factor. What we're getting into now is not necessarily about factoring. It's more about finding factors, finding all the things that divide evenly into something. Now, what do you think? Is this hard? Is it difficult? No, just a lot of steps, right? And it takes a while. That's it. So, this is all we're doing today. This is our objective, is doing our long division. So let's get a few more examples in here and a little bit of their blah, blah, blah that they have to tell us so that we know where this is going. Because the remainder for each of those was 0, they are factors of the dividend. And so the 21 went in evenly, didn't have a remainder. The 2x plus 1 went in evenly, didn't have a remainder. Now that means that the remainder was 0. And that's what comes out here. This key concept says, if we take something and divide it by another polynomial, we'll get a dividend. It's actually given us the fancy language. You can divide a polynomial p of x by d of x and get a polynomial quotient q of x and its remainder r of x. And that's what was going on. It just happened with the examples that we did that our remainder down here was 0. And if that remainder is 0, well, that means it went in perfectly. It divided perfectly. So if r of x equals 0, then p of x equals d of x times q of x. Remember when I wrote down the 2x plus 1 and the 3x, what was it, plus 2 or something in there? Those are the factors. To use long division, p of x and d of x should be in standard form. Makes it nice, they're all lined up and everything, with 0 coefficients where appropriate. So let's just say they give us this one. That's missing something, right? So think about standard form. What should we put a 0 in for? What's missing if we write that in standard form? Standard form is the highest power on down until you get to x to the 0. This is missing one of those. Which one's not there? Three, 2, x squared. So here's what they're saying. If something's missing, put a 0 in for it to keep track of it. Don't lose it. Don't lose it. You want to know that that process is there. So the process stops. We'll know we're done when the degree of the remainder is less than the degree of the divisor. When we can't multiply by something to get the match. That's when we have to say this is done. It's finished. So 0s for anything that's missing. That's helpful with polynomial long division. It is a must when we do synthetic long division tomorrow. So it's a good habit to get into that if anything's ever missing, put a 0 in its spot. Anybody need more time to get that down? All right, we're just going to do some more examples. So, polynomial problem number 1, using polynomial long division. Use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. What is the quotient and remainder? So this time they're kind of giving us a heads up. It's not going to go in perfect, and that's real life. I mean, real life, very rarely does our polynomial division work out perfect. All right, so we have x plus 5 as our divisor. And we have 4x squared plus 23x minus 16 as our dividend. Let's get started. Focus is only on the first term. How are we going to get x to equal 4x squared? Exactly. Multiply by 4x. Perfect. Now again, we get what we want with the first one. The second one we have no control over, and that's okay. We just want to make sure we do it right. change the signs, and then you can add them together. So 4x squared minus 4x squared, perfect. That means this little 4x right here can go right up there as part of our answer because we did it right. We got that first term out of there. 23x plus a negative 20x, or just think of it as subtraction, gives me 3x. What's my next step? Bring down the 16. Yeah, I don't have enough to go with here. So now I bring down that 16, and I start over with x plus 5. What should I multiply by this time? Yep, just a little 3. Then we'll have 3x and 3x. And then we'll change the signs and think of adding vertically. So 3x minus 3x, perfect. This little 3 going right up there. But then we have negative 16 plus a negative 15. Well, that didn't go in perfect. No. And like I said, most of the time, they don't. They don't. So, in elementary school, you learned, first you wrote the great big R. Do you remember that? And the teacher would have you do that. That seems so long ago. Put R and then your big remainder. And then you learned later on, that's really not what's going on here. What's going on here is we have this remainder because we were trying to divide by x plus 5. And things didn't work out quite so perfect, you know? And like I said, that happens more often than not, that it just does not work out perfect. So our remainder should be the top part, the numerator of a fraction, where our divisor is on the bottom. So this one would be kind of weird to check it, but we could check it because we could take x plus 5 times 4x plus 3 and then add our remainder. Because that's what remainders do. You know, they're the number that kind of sticks out like a sore thumb. They're not doing the normal stuff. And in fact, that's what goes on in this little check down here. Because everybody's great at FOIL. So if we took x plus 5 times 4x plus 3, that would give us 4x squared plus 3x plus 20x plus 15. And then we have to subtract that 31 in the back. And it works out perfectly to 4x squared plus 23x minus 16, which was the dividend up there, what we were trying to divide by. So they can be checked. You know, it's not like plopping them into a calculator, but it's checking. All right. Got it, 1. We're going to use polynomial division to divide 3x squared minus 29x plus 56 by x minus 7. So the quotient is the rest of the answer. The remainder is that number at the end that just didn't work out perfect. All right, I know you've already gotten a start on this one. What are you multiplying by the first time? Yes, exactly. Change the signs. You say, yes, 3x squared minus 3x squared is 0. I want to put that little 3x right up there. That's working so good. Negative 29x plus 21x, negative 8x. And we bring down that lovely 56. And we start again. So now what do we have to multiply by to get rid of that first term? Yeah, feels kind of gross, right? Negative 8. We have to, though, because we have to make it match so that when we switch the sign, things are going to work out nice. So negative 8. realize, hey, that wasn't so bad after all, because if I change those signs, negative 8x plus 8x is 0, which means my negative 8 worked great. And 56 plus negative 56 is 0. So a remainder of 0. So with these two problems, really what they were trying to get us to see is there's a name for both part of your answers. The name for this part, whoops, is that blue again that doesn't like to work. That's the quotient. And of course, we learned many, many years ago that whatever that number is down there at the bottom, that's the remainder. So this is another one that worked out perfect. This is one where if you took x minus 7 times 3x minus 8, you would absolutely get 3x squared minus 29x plus 56. Absolutely would. Wow. Like we said, it's steps. You know, if you know the steps, it goes well. But we need practice at it, especially at more difficult ones. So this one says, okay, let's kind of switch gears here. We just want to know, is x squared plus 1 a factor of that big mess that we see back there? And at this point, the only way we have to know that is if we divide it and we get a remainder of 0. Then it's a factor. So that's what we'd have to do. But be careful with this one. Remember, highest power on down, and if anything's missing, you have to put a 0 in for it. We need that placeholder, that 0 in there to say, okay, there's not really an x term here. But one might show up as we're going through our math, so we have to make sure it's there. All right. Here's what we start with. What should we multiply that by to match just the first term? 3x squared it is. So 3x to the 4th is what we get. But we also get plus 3x squared. Well, that can't line up here. These are the cubics. So I have to move it over here. It's my job to know, hey, I line these up vertically, up and down, to make sure I get what I need. Change the signs. 3x to the 4th minus 3x to the 4th is gone. So I'm going to put my little 3x squared up there because that worked out perfect. But wait a second. If I just go to the x squareds, what happens to this negative 4x cubed? Well, we have to bring it down because we haven't done anything with it yet. So we have to bring that along. And then we start again. All right, what are we going to multiply by to get our negative 4x cubed? Bill, stay with us. What are we going to multiply by? Negative 4x. So negative 4x to the 3rd minus 4x, which again doesn't line up right, but we're going to put it where we know it's supposed to go. Lining up with the x's over there. Change the signs. Add. Ooh, good stuff. Negative 4x to the 3rd plus 4x to the 3rd is 0, so negative 4x goes right up there as part of my answer. It worked out perfect. But this 9x squared has to keep coming. Plus 4x. Might as well bring down the 5 while we're at it. See what happens. And we start over. What do we multiply by this time to get rid of that first term? Yes, a 9, because we need that to be a 9x squared. And it is. We also get a plus 9 out of that. So we put that underneath the other constant that we have over there. And then we'll change the signs. And 9x squared minus 9x squared is perfect. So we've got our 9. But we've got that 4x hanging in the air. And 5 minus 9 would be minus 4. Well, let's go back over here. Well, what do we multiply x squared by to get it to be 4x? You see how we're at the point where we have to stop? Yeah, we can't. You can't multiply x squared by something and make it x. We'd be dividing to make that happen. So that little red 4x minus 4 down there, that's my remainder. So I'm going to put plus 4x minus 4 over x squared plus 1. All to answer this question. Was it a factor? Did we get a remainder of 0? No. So we have to put no. But that's how we check. If it divides into it evenly, nicely, then it's a factor. All right, we have another one down here. My blue line seems to be right in the middle of that. There we go. Oh my goodness, look at this one. What do I need a whole lot of for this problem? A whole lot of zeros. Yeah, because we go from x to the 5th all the way down to the constant of negative 32. Now this is an example where you definitely don't skip the zeros, you know. Because like I said earlier, some people skip the zeros and just try to keep track of things with long division. But not this one. There's just too much going on. Tons of missing pieces. All right, can you get me started? I have x minus 2. I need x to the 5th. What's it going to need? X to the 4th. Exactly. So we're going to get x to the 5th, but we're also going to get, and here's why the zeros were important, negative 2x to the 4th. So it worked. I'm going to put my x to the 4th up here. Change the signs and add. So now x to the 5th minus x to the 5th, gone. Toast. Then we get 2x to the 4th, and I know normally I'm supposed to bring down the next term. So that's what I do. Bring down the next term. So now what are we going to have to multiply by? 2x to the 3rd it is. So we'll get 2x to the 4th. But we will also get minus 4x to the 3rd. Change the signs and add. Our 2x to the 3rd did its job, so we put it up there as part of our answer. We're going to end up with a 4x to the 3rd. And we bring down the 0x squared. We're getting there. It's just taking some time. And we start over. So take a peek. What do we get? 4x squared. Perfect. So 4x to the 3rd minus 8x squared. Change the signs and add, and it did its job because that 4x to the third is going to be gone. We will have 8x squared plus 0x. And yeah, I write too big. Let me move that one down. Alrighty, back over here again. What do we need now to make a match? 8x. So 8x squared minus 16x. Same thing, we'll change all the signs, and when we do that, we see, oh, excellent, it worked. So we write our 8x up here. And bring down the next term. Oh, that looks awful. Whew. Got to be close, right? All right, so what are we going to multiply by this last time? 16. And look what happens. Here's our little 16. And when we switch the signs and add, yes! So let's answer the question. Is x minus 2 a factor? Yes, we got a remainder of 0. Now, I know here in the room, it seems like everybody's getting everything that they need. Is there anybody on the Google Meet, because we do have got it 2A left, is there anybody on the Google Meet that's saying, I want to see one more? Then we'll do one more together. All right, but I'm just going to give you the homework and let you spend your time working on this. Polynomial long division. Starts off sounding kind of scary, but it's not that bad. So there you are. 5-4 day 1, page 308. 9 and 19 the odd, and 44 and 47. Obviously, there's a lot of work to show on these, so make sure you're doing that. Those of you that are home, show your work on everything as you go through, and everybody here. And don't forget to check your emails in case I had to send you an email reminding you to turn in your work for the test. But if you're one of those people, please email it to me. Otherwise, we risk maybe you submit it in the wrong spot and I can't find it. All right, work time.